yesterday as we looked at all the different means, okay, we talked a little bit about, when we got to our final question, about the difference between when you had 5 rolls of the die versus 10 rolls versus 30 rolls. And the more rolls we got, the more our answers started to become the same, didn't they? Okay, so we were working on really just kind of eliminating that margin of error. Okay, so we're going to look at examples that will take us into the discussion of margin of error. We won't really probably get to start finding any margin of error till tomorrow, but head that way in our concepts. So let's look at this example. We're going to talk about being able to estimate a population parameter. So be able to estimate information for the population. Seth selects a random sample of students from a local college. Excuse me. Thank you. Okay. He asks students their year in college and how far their college is from their home in miles. So this chart here is Seth's information. Okay. You've got each of the people that he surveyed. He was able to get what class they are, so freshman, sophomore, junior, senior, and then the number represents how far their college is from their home in miles. So, first question. Some of these we have answers, sometimes we're more discussing. How can Seth's sample estimate the proportion of freshmen in the population? So this is a sample of the students at his college. How can he use this sample here to estimate the proportion of freshmen at his college? Any thoughts on what we could do here?
Figure out how many freshmen he asked in relation to the amount of kids in the other grades he asked.
Okay, so so how many freshmen he asked in relation to how many total students he asked? And that's going to give us a proportion of freshmen in his sample, right? Now, what's the idea of a sample? A sample represents the population, right? Okay. Sometimes they're good samples, sometimes they're bad samples. We're not saying a sample is always a good representation, but the sample is going to represent the population. So that's exactly what we're going to do here is we're going to find the proportion of freshmen in this sample, and then that's going to be an estimate of the freshmen in the population. Okay, depending on what kind of sample he found, whether he did a truly random good sample or whether it wasn't a very good sample, will depend on whether or not, it's a good representation. So what do you notice here about freshmen?
There's only 4.
4 of them? Okay, so 4 freshmen. How many students did he sample? 20 students. So what do we know? If he sampled 20 students, 4 of them were freshmen, how do we set that up? 4 over 20?
20%.
And 4 over 20, if we reduce that as a fraction, what is as a fraction? It can go to 2/10 and becomes 1/5 as a fraction. Now, I'll be honest, off the top of my head, I don't remember exactly how you're answering questions in what form, but it's, you're going to see a variety between 11.5 and 11.6. And so it could be 1/5, or what could this be as a decimal? Okay, it's 0.2, or in other words, 2/10 as a decimal, or as a percent. Now I'll take the 20%. Okay. So there's his actual sample. How did we do that? Because I am trying to write some notes today. We found the proportion of freshmen in the sample as it represents the population. Okay. So I'm going to write down, find the proportion of freshmen in the sample as an estimate of the population. Okay, so write as much or as little as you're wanting on these. Some of these I'm doing lots of writing today. But we looked at 4 freshmen out of 20 students sampled. So we found the proportion of freshmen in the sample, and that represents the population. Okay, again, might be a good representation, might be a bad representation. We don't really know, but that's our population representation there. Now, when you're ready, read the second question. How accurate is the estimate likely to be? Thoughts? How accurate is this one? What makes a sample more accurate?
I don't want to say it's not because it is, but it isn't. Because like the amount of freshmen, like it's random, but that means you could get 20 seniors and 1 freshman. But since we're looking at the distances, that's likely.
Well, right now, don't worry about distances. We'll talk about distances.
We're looking at how much freshmen.
Like how accurate is 20% accurate? Do we think?
No.
Maybe 50%.
Okay. Why are we thinking it's not accurate?
Because you could have, it's like on this sample, he could have 4 freshmen, but on another sample, he could have 10.
Okay. So, and what's that relate to? That relates to
Location.
how did he get his sample, right? What was his location? Did he question friends? Did he question random people? Did he, I think it was brought up first hour, what grade is he? Did he question, more of his friends, and how does that relate?
People that he wasn't scared to talk to.
Okay, so, part of this is, okay, what kind of, it says random, but is it truly random, and how, so did he use a good sample? Okay, the better this sample represents the population, the more accurate it's going to be. Now, do we have the knowledge to know exactly how accurate this is? We don't. Okay. Another thing we can talk about, how many people did he sample here? 20. How many people do you think go to this college?
Probably a lot more than 20.
Okay. And we don't want to sample, a sample is not everybody, right? However, a sample of 20 compared to how many kids at this college? Is that a big enough sample, do we think?
Probably not.
And again, do we know? I don't know, maybe this is some crazy college where there's only 100 kids at the college. I don't even know if something like that exists. But, we don't really have enough information to know. But those are some thoughts of, okay, what would make this more accurate? And the larger the sample, the more accurate it's going to be, and the better the sample it is. Okay, the more random the sample and just the, more diverse the sample is, the better it's going to be. Okay, in all honesty, 20% being freshmen, honestly, it sounds kind of low to me, just because I would expect, personally, which class would you expect to be biggest at a college?
Freshman.
I would say freshmen, because you get all the incoming freshmen before
They drop
people,
out and they realize, oh crap, college is for me.
they drop out or they transfer to another college or something like that. So, okay, so those are the 2 thoughts I was going to put here. Again, we don't know for sure on this one. These are just thoughts. So I was going to say the larger the sample, the more accurate it is likely to be. Larger the sample, the more accurate it is likely to be. That was one point that we talked about. And just the better the sample represents the population, the more accurate it will be. So the better the sample represents the population, the more accurate it will be. Again, write down your information. And once you've written down that information, start thinking about the next piece of this question. The next question says, use the sample data to estimate the mean distance from home. What are you guys pulling out right now?
Calculator.
Calculators, yes? Because they're asking us to use this data we were provided to find the mean distance from home. How do we find mean?
Add them all together, divide by how many there are.
Okay. Add those numbers and divide by the number of numbers. So that means we're dividing by what?
20. I got 101.
That's the rounded answer, I assume?
No,
Yeah.
That's a rounded version of what I have.
mine's just straight 101.
You hit a wrong calculator button and you're just
But I still got the right answer.
teensy bit off. Well, it's not. I'm not going to write 101 up here.
But it asks for an estimate.
Well, your estimate because it's a sample.
Yeah.
We don't have all the population's information, so
I got it. Yeah, I put 123 instead of 120.
see, told you you're just slightly off. Okay, what did these numbers total up to be when you added them? Anyone know that?
2017.
2017. And when you do 2017 divided by 20, you get 100.85, and that label would be miles. Okay, and again, that's an estimate, right? We're using the sample data to estimate. Okay, is that accurate?
Oh, yeah. But
I don't know. It's hard to tell. Okay, I do think maybe it's a little higher than it should be, and why would I say that?
Like 5 miles. 5,
There's a lot smaller numbers, but then there's
the 800.
that 800 really kind of throws things off, doesn't it?
Yeah.
Okay. But again, this is the sample we have. This is an estimate. The sample is only as good as the data collected. Okay. And one more piece in this section. Estimate the proportion of seniors to the total population at the college. So what are we doing here?
Same thing we did for number one.
Okay. Same place we start off with. In this case, we're talking seniors, and we have just 3? Okay. 3 seniors out of 20. What do you know about 3 out of 20?
15%.
Okay. As a decimal, it is 0.15. And as a percent, it is 15%. Okay. Any of those forms could be used to estimate the proportion. Okay. Okay. Now, while we're moving on to the next piece, don't for 1 minute think we're leaving Seth behind. Seth is still part of this next piece of the problem. Okay? Okay. As you look at the bottom piece, Tia is contributing to the same project as Seth and has sampled a different group of students. So we have Tia's data here. She also sampled 20 students. Okay. The proportion of freshmen in her sample is 0.4 or 40%. Okay. how can Seth and Tia determine whose result is a better representation of the population? Okay, so they're not even going to make us find it, but we know that Tia, her freshman is 4/10 or 40%. Okay. What do we know about Seth?
His was 120.
Yeah. His freshman percent was 1/5, 2/10, 20%. Okay. So with that in mind, thoughts. How can Seth and Tia determine whose result is better?
You can't.
Okay. What are options? We can't right here, can we? We don't really have enough information to determine is Seth's better or is Tia's better. Okay, but what could they possibly do? Okay, they're at this college. What could they do?
Figure out the actual percent of freshmen in the population.
Okay, look what the actual percent might be. What if they don't know that actual percent?
Better find it.
They can find it out.
How can they find it out?
Ask somebody that knows.
The admissions.
Okay.
Ask
What can they do as part of this project, folks? What could they do to get better samples here?
Ask more.
Or more accurate answers, I should say.
Ask the same number of each group. So 10 freshmen, 10 sophomores, 10 juniors, 10 seniors.
So then your percentage would change. And maybe
I
their
think I'm talking about
percentage would be the
distance.
same.
I would say if we're just talking about distance, sure, but in terms of freshmen,
Just ask more people.
could they ask more people?
Yes,
Instead of using 20 people as a sample size, could they make a bigger sample size?
200.
Okay. Is that an option? For them it is, yeah. And that's, the more people we ask, again, the more accurate it's going to be. So they could ask a larger sample size. They could, just in general, asking more people here. Okay. Yes, could they go to admissions and find out the actual and compare? They could, but if we're just trying to go based on their project here, how could they get something better? Okay, and so we don't have enough information to know right now whether Seth's or Tia's is better. Okay, we just don't know that yet. Okay, we'll continue with Seth and Tia on the next page and we'll find an answer. But at this point, the best suggestion for Seth and Tia is to examine more samples or larger samples.
Let's just stop here.
So I'm going to say Seth and Tia can examine more samples or larger samples. Whichever way you want to go with that. Okay, so more samples, larger samples would be the two directions you could go. More samples being other samples of similar size, or just increase their size. 100, 200 people is going to make a big difference compared to 20.
Hang on, turn my phone down.
Okay. Get what you need. After you get what you need, then flip to the next side. Start looking at the next piece. Okay. As we look at the next page, we find out that everyone in Seth and Tia's class completed the same survey. And we are given a histogram of results. This histogram shows the results of the 50 total samples of 20 college students each. So it's not just Seth and Tia that did this. It's Seth and Tia and 48 other classmates. Okay, so what we're looking at here is this is the result of 50 people doing the same survey. Okay? And along the bottom, you'll notice that these are the results of proportion of freshmen. So 0.1 up to 0.4. Okay. Along the left, talks about number of samples. What shape does this have? What?
It's normal.
Yeah, do you remember talking about normal distribution in our previous lesson? You know, we talked about the last couple lessons how something could be skewed or it could be symmetric. And when it's symmetric, it has that normal curve shape, doesn't it? Do we see that normal curve shape here? Yeah, it's not precise, is it? It's not perfect and exactly normal, but does it have the basic shape? And that's what you have to look at and consider is, okay, it has the basic shape here. Now, with that in mind, okay, let's go back to our discussion about Seth and Tia. Okay, one of the options we said we needed larger sample sizes or just more samples. Basically, we needed more people's responses. We have more people's responses now, yes? So thoughts now?
I think Seth is better than Tia.
Okay. What did Seth have? Seth had
20%.
20%. So Seth's was right here, whereas was Tia's?
All the way
Off
right.
the leading chart.
It was at 0.4, yes? As we look at this, where is the majority of our information here?
120.
Okay. I mean, you've got all this normal curve, and if you go back, you guys remember our empirical rule, right? Where it was 68, 95, 99.7, right? Okay. If we focus, and what they tend to focus is on is like the 95% being the majority of the data here. Okay.
That's fine.
Because keep in mind, these were all their averages surveyed and added up, right? And you've got the majority of the information here. And I'm going to pinpoint on the area. If you think in terms of a normal distribution, I know this isn't divided up exactly, but if you think in terms of that way, where you've got like the middle, you're kind of going out approximately 2 standard deviations, then basically if you ignore those little tails, majority of our information is going to fall between 0.1 and 0.35. Okay? 0.2, it's definitely in the midst, isn't it? Okay? 0.4, it's at the very outside. Okay? So those ones in the middle are going to be better representations. Okay? Let's see, I'm trying to think. And it's not even really asking a question here, but I'm basically just continuing with what we just talked about. So let's see, we talked about that it's approximately a normal distribution. Most of your responses, if you look at that kind of 95%-ish look, are falling between 0.1 and 0.35. So with that in mind, it's reasonable to predict that the percent of freshmen, depending on the situation, are going to be anywhere from basically, what is that, 10% to 35%. And that makes Seth's result the better representation than Tia's, yes? Okay, so I'm going to write several of those pieces of information. First one, I'm going to remind us that it is an approximately normal distribution. Throwing that vocabulary in there, I don't want you to forget. Most responses fall between the 0.1 to 0.35. So you can expect proportion of freshmen to be between 0.1 and 0.35. then last comment I'm going to write is about Seth and Tia. So that middle one kind of got lengthy there. Most responses were falling between the 0.1 and the 0.35. Okay, so you can expect the proportion of freshmen to be between 0.1 and 0.35. And then that takes us to Seth versus Tia. And Seth's result is better than Tia's result. Okay. Now, write down what you need. And then start looking at the next piece where we talk about, we get to actually talk about the average distances a little bit now. Okay. Each classmate calculates the mean distance home in miles reported by participants. So now we're going to talk about mean distance. Seth and Tia create this histogram to investigate the sample statistics. How many samples reported an average distance from home between 101 and 125 miles? Excuse me.
That's it.
Hearing six or seven. Why?
Because, well, you have to go down on the chart where it says 101, go to 125. Then you have to look over on your y-axis and see where that lines up with.
Okay. So we're going 101 to 125, which is going to represent this bar right here. And what do we know about, what does it look like on this bar?
4 and 8.
Okay, between 4 and 8, and it kind of looks to be central, which would put us at,
6.
I would say 6. Okay, and realizing these numbers at the bottom are mean distance from home, the numbers on the left are number of samples. So remember, there were 50 students that did this, right? There were 50 different samples. So of those 50 samples, we're saying about 6 had results in the 101 to 125 range. So 6 samples have an average distance of 101 to 125 miles. That's what I have written here. 6 samples have average distance of 101 to 125 miles. Okay. And we didn't really talk about it before we went into this. This curve. Is it looking kind of normal again? Yeah. I mean, there's a little piece here that's maybe a little lower than it should, but does it still have that kind of normal curve? That if you follow this up and follow it down, it's still going to end up with that normal shape. Okay, so realize that normal shape is happening again. Our other question here, our last question with Seth and Tia before we move on to other people. Use the histogram to suggest a reasonable interval to estimate the population parameter. So again, this is samples, right? So right here, we're looking at the sample. What do you think? What's a reasonable interval to suggest that a lot of students fall in?
Would you want 75?
Okay.
Or you just one?
I have more than one. I have a bigger range.
26 through 75.
Now, as we talk about that,
Or it could be actually.
yeah, it's trying to read this, isn't it?
Yeah.
It's weird the way it's set up, but I don't have control over that.
It would be what, 26 through, oh yeah, I don't know. Just tell me the answer.
Tell you I want some discussion first. Jeez. He just wants to know.
I'm just tired of reading this chart.
I do agree. This chart is kind of weird to
Anyone else breaking spring break?
read. I think we're all ready for that, Jay. Okay, so definitely, I think everyone could probably definitely agree that these middle two bars are definitely high, aren't they? Okay, so when we talk about, interval, I think those two definitely need to be involved in the interval. And that right there is what? Going to be 50 to 100. Now, if we go along with the whole normal distribution curve here, okay, and looking at that, we're looking, if we kind of go along with the idea of that, taking off the tails, looking at the majority of the information here, okay, we are looking at, it's almost kind of like the 95% again, okay, in other words, we don't have an official percent here at this point, but looking at that main middle piece. We could really go either way. We could just talk about the middle two bars. We can talk about the middle four. Okay? That's not your test, is it? Okay.
No, this is just the classes.
Okay. So with that in mind, I have the average distance from homes being those four middle bars, which is the 26 to 125. Again, could we argue other ways? We can. Okay. So if you wanted to say just those middle two, I could follow along with that too. There is kind of an opinion involved too here. So, but I have written down the average distance from home. Is likely to be between, what did I say, 26 and 125 miles.
It's a large average.
It is, in a way, but I mean, that to me, I'm looking at, okay, that's half hour to 2 hours away. Is that a typical college, distance from home? It's not unusual. I would say it's pretty much the norm. Okay, now, are there things like, that 800 we saw on the other page? Are there people that are 800 miles from their home when they're at college? Yes. Are there people that are 2 miles from home, 5 miles from home? There are the extremes, but I think that a big portion of the population, again, that's half hour to 2 hours away. I think that's common. Okay. Okay. Ready to be done with Seth and Tia?
Yeah.
Okay. We're going to go talk about, I think it's Gabriella and Alex now. Let's see, are we at a position that we are caught up here? Okay. The situation we were just looking at, Seth and Tia were able to go and sample. Okay, they were able to go out, they were able to get some data by talking to people. While that is sometimes the case, that is not always an option, depending on the scenario here. With this scenario, we're going to talk about how you could use a simulation to evaluate a claim. And as we talk about using a simulation, the idea of a simulation, this is something where your calculator can do this. Excel spreadsheet can do this. But where you can ask a calculator or some technology piece to generate so many random numbers. And those random numbers can represent responses. Okay? So in this scenario, Gabriella wants proof of Alex's claim that he is a 75% free throw shooter. She observes Alex shoot 53 throws, of which he makes 30. Gabriella notes his 60% success rate. But Alex points out that this is a reasonable result due to the natural variability that happens from sample to sample. Is he correct?
Yeah,
Sounds pretty scientific to me.
it sounds good.
Sounds
I
good.
would
Let's
believe
move
it.
on, huh?
If you told me that,
If somebody said that to
me,
me, I would believe
I
it.
would believe it.
Okay.
I mean,
Okay, well, let's look at the data behind it here, okay? But, I mean, you know, if you claim you're a 75% free throw shooter, does that mean you're always making it 75% of the time?
No.
No, not necessarily. Okay, depending on, you know, the scenario we're looking at here. Now, in this situation, okay, this is the idea of using a random number generator to investigate this a little bit more. To decide, you know, is Alex's claim legit, or does Gabby say, you know, hey, that was only 60%. You're full of baloney, okay? So, now, right here, let's look at what's on this chart. First of all, notice it says rand between 1 and 100. So what that's saying is that the random number generator produced random numbers between 1 and 100. And how many numbers do we have here? I think it's 5 by 10, so we have 50 numbers here,
What?
right? And realize, I know I had a question this morning. What's these letters? D, E, F, G, H, I, J, K, L, M. This is like a piece of a spreadsheet. Okay, this is like doing this on an Excel spreadsheet or something. Okay, so there's 100 numbers between 1 and 100. So in this first box, the computer said pick a number between 1 and 100. In the second box, the third box, it just over and over kept saying pick a number between 1 and 100. Okay, it did that obviously 50 times. How can we use these numbers? And I'll tell you, there's a hint, because on mine there's a color difference, isn't there? Okay. What do the orange numbers represent versus what do the blue numbers represent?
Those are the highest numbers each column.
Okay. So I think Eli had the idea here. Orange numbers are numbers that are below 75. Blue numbers are the numbers that are above 75. So what are those numbers? If he claims, so this is Alex's claim, that he's a 75% free throw shooter.
Those are the ones he's missing.
Now, if he's a 75% shooter, he's making it 75% of the time, then these orange numbers that are below 75 are the times that he is, no, it would be the times he is making it. Okay, it's the times that he is making that shot. Because and you can assign it however you want. Okay, but in this scenario, because of the color difference, 1 through 75 represents, okay, if he gets any number between 1 and 75, that's representing the 75% of the time he is making it. What's that mean about 76 to 100?
He's missing.
That's the other 25%. Those are the times he's missed it. Could these pieces be reversed if you had chosen that way? You could. You could have said 1 through 25 was missing it, and then 26 through 100 is making it. Okay? But in this case, all of these numbers below 75 are the times he is making it. Okay? And that's based on his claim. Now, did anyone happen to count how many times I just circled?
No.
1, 2, 3.
It's 4 in every row except for 2.
11, 39.
I think 39 is what I had.
Not 39.
Yep. Okay. So what is this simulation saying? He made it 39 times out of 50. What is 39 out of 50?
78%.
78%. So based on this one simulation, what could we argue?
That he's being generous.
That he is a 75% shooter. He can make it 75% of the time. Okay? Now, with that in mind, this was one set of 30 shots that Gabriella watched, and he made 60%. This is one simulation. This one simulation said he shot 78% of the time. Is one sample enough to know?
No.
Not necessarily. So, what I want to do here is just write some information about what was going on in this problem. the fact that, first of all, this is using a random number generator. And when we talk about random number generator, that is on a calculator or a spreadsheet like Excel. Okay. In this particular scenario, what? Numbers 1 through 75 were a make, and then 76 through 100 were misses. So this random, so generate numbers 1 to 100. Okay. Based on the 75%, let 1 to 75 be successes, makes, however you want to put it. Then 76 to 100 are misses. What did we find out in our scenario?
78%.
39 out of 50, which is 78%. Okay, and the idea then, also the one simulation is not quite enough. We'll talk more tomorrow.